Now we'll see gate problems related to memory architecture. The question number 1, which is asked in GATE 2015, assume that for a certain processor, a read request takes 50 nanoseconds. Let us imagine that this is your processor, okay? So whenever you request a read, then it takes 50 nanoseconds. But when on a cache miss, okay, there is a cache, sometimes there is a miss, right? So when cache miss, there is a penalty, and there is a chance that cache might hit. So there are two cases. We have to see what happens in each case. 50 nanoseconds on a cache miss and 5 nanoseconds on a cache hit. That means the processor takes 50 nanoseconds whenever there is a cache miss and 5 nanoseconds to get the data whenever there is a cache hit. Suppose while running a program, it was observed that 80% of the processor's requests result in a cache hit. So what is observed? 80% of the time there is a cache hit. Now the question is the average read access time in nanoseconds. He has given everything about readings, right? Now we have to find out average read access time. So if you see, in 80% of the time we will be hitting the cache, only 20% of the time we will be missing the cache. Let me divide the problem into two cases. So here, remember one thing, they have not given you cache access time at any time, correct? So they have not mentioned anything about cache access time and main memory access time, right? So they have given complete process. You don't worry about that cache access time and main memory access time. They have given the values in a different way. Whenever there is a cache hit, then to get the data it takes just 5 nanosecond. Whenever there is a cache miss, so what that processor will do doesn't matter for us, but end of the day we will be having penalty 50 nanosecond. Now the problem is very simple. To find out the average access time, we have to divide all the cases into two parts, right? Now see, all case number 1, case number 2. Case number 1 is nothing but cache hit. Case number 2 is cache miss. So the probability of hitting the cache is 80%, correct? So 80% of the time, what is the penalty? 20% of the time, what is the penalty? If you find out, then you get average access time, isn't it? This is the formula. 80% of the time read penalty plus 20% of the time read penalty is nothing but total average read penalty. We will see. So 80% of the time we will be investing only how much time? Because clearly mentioned 5 nanoseconds. And 20% of the time we are only investing 50 nanoseconds. Some students will have this doubt. Sir, 20% of the time we have to invest 50 nanoseconds plus 5 nanosecond. That is wrong, because this 50 nanosecond plus 5 nanosecond formula, when you assume this 50 nanosecond as main memory access time and 5 nanosecond as cache access time, but this 50 nanosecond and 5 nanoseconds are not explicitly cache access time and main memory access time. This entire 50 nanosecond might be, because they have clearly mentioned that this 50 nanosecond is the total amount required to fetch the data when there is a cache miss. That's why. So we don't require to do anything else. Simply take 80% of the time 5 nanosecond, 20% of the time 50 nanosecond, right? So then you don't require to apply that process. Then 80% into 5 nanosecond. What is that? If you simplify, it would be 400 nanoseconds plus 20 into 50, 1000 nanoseconds by 100. Then I can cancel like this. 2 zeros here, 2 zeros here. It would be 10 plus 4, 14. So 14 nanosecond is the final answer. Right? So here don't apply that formula, because that formula is not applicable here, correct? Because they did not give you cache access time and main memory access time. If they give cache access time, main memory access time, then probably we can go for that formula. That's it.